Good day, ladies and gentlemen. My name is Luke Magayo, Level 42 Computer Systems Engineering, and I'm going to be presenting my project entitled IoT-based air pollution monitoring system. So, to begin with, I'm going to start by showing you the components I used for this project. First, we can see this Wi-Fi module, ESP32, is going to be there to assist in making it possible for me to be able to connect to the internet and for Wi-Fi capabilities. And this that you see here is the MQ7 gas sensor. It's the one which is going to be acting as an input to detect the gas that is being polluted in the air. It measures various types of gases, including carbon dioxide, alcohol, benzene, LP gas, and more gases. So basically, for this project, its aim is to precisely monitor air quality, such as, for example, carbon monoxide in the air, and efficiently upload real-time data to the cloud-based server. Okay, moving on. So now I'm going to state the objective of the system that you see here. So objective number one is to design and implement an automated IoT-based air pollution monitoring system, which requires little or no input from the user. So as you can see, this little device here is actually no need for any human to be there. It actually connects to the internet itself and captures data using this MQ gas sensor. Objective number two is to analyze or have analysis of real-time air pollution monitoring of carbon monoxide levels. Then this is what we will be using to do that. Number three is to integrate Wi-Fi capabilities for remote access and allow monitoring of the air quality over a web server using IoT. Then we'll be using this Wi-Fi module. It can work as a microcontroller as well. So all the code is written in this Wi-Fi module, and it allows us to connect to the internet. Number four, to have cloud storage for data logging. So this Wi-Fi module is going to be connecting to the ThinkSpeak website where our data will be stored. Then lastly, to graph data over time for analyzing. Then this is going to be saved on the ThinkSpeak website so that we can then use the graphs to analyze. So now we are going to move on to the ThinkSpeak website so that we can see exactly what's going on. So now, as you can see, okay, so here as you can see from my channel, it shows that the last entry is in less than a minute ago, and from my graph here you can see that today is 16 March 2022 and the time is 9:20 GMT. So this shows that there is live monitoring of data and real-time update of the system. Now we are going to try to add a bit of carbon monoxide and see if the levels are going to increase. So here with me I have a tissue, and I'm just going to try and make an incomplete combustion. I'm going to refresh from this side as well. Then you can see here that the levels have also increased. So it now means that our room is no longer safe for us. So we have to open up and add new fresh air. As you can see that the graph has actually gone high, meaning that to say that there's more carbon monoxide in this room. But after clearing up the carbon monoxide, then we refresh, you can see that the graph is now slowly making a step, and you can see that our gas levels of carbon monoxide are actually reducing. Shows that our project is responding very well. And it can show that this was updated less than a minute ago. So just now and every 30 seconds it updates. Every 30 seconds it updates. So this system can also work, especially in mines. When people blow explosives and there are gases down the mine, they can actually detect if it's now safe to go under or it's not safe, so that people can now get back on top and wait until the air levels and air concentration has been balanced, so that people will not suffocate from carbon monoxide and other dangerous gases. So the basic aim of this project is just to monitor air pollution levels, and this project can be used in various places, including the mines, including offices and other dangerous areas where humans can find it hard to detect different kinds of dangerous gases that are in the air using their own nose. But this sensor is actually helpful in this part. So as you can see, the other different thing about this project is that it's very small and it's actually power efficient. It saves power. It also saves number of components that should be used. So instead of using an Arduino board, we are now putting everything down on this ESP Wi-Fi module, and all the code is written in this Wi-Fi module. Also, the PCB of this project is very small. It saves energy. The code snippets are very small, because this Wi-Fi module is not going to be integrated to other microprocessors or microcontrollers like the Arduino board, and hence this project is very efficient, and also it's cheap and affordable to create a simple project like this one. Thank you guys for taking your time to listen to my presentation.